Hi.
All right. Hi, Maddie. Can you see my screen?
Yeah.
Okay. All right. Let's start today's lesson. So, today's lesson is going to be on the forms of a line. And there are three fundamental forms of a line that you need to be familiar with. The first one is the slope intercept. And this is going to be the most popular and most useful, especially for graphing. Okay, because slope intercept form is going to give you the intercept, the y-intercept, and the slope.
Yeah.
And given a y-intercept and a slope, you can graph pretty much any line very easily. The second form of a line is the point slope form. Okay, and this is good if you are given a point and a slope, not an intercept, but a point. Okay, an xy ordered pair and a slope. The third form is the standard form. Okay, and we're going to go over all three. So the first form is the slope intercept form, and the general form of the slope intercept form looks like this: y equals mx plus b, where b is the y-intercept, and m is the slope, x is your x value, and y is your y value. Okay, and just to recall, what is the y-intercept?
The y-intercept is where x equals 0.
Yeah, so in this equation, mx plus b for slope intercept form, if you plug in a 0 for x, this cancels out and you're going to get y equals b. Okay, yeah. So b is going to be your y-intercept. It's where x equals 0, or where the graph crosses the y-axis. Okay, and what's the x-intercept?
Where the y equals 0.
Yeah. So given a line that slopes downward like this, in other words, it's got a negative slope, your y-intercept, so the y-axis is that, the x-axis is that, your y-intercept is going to be here. Okay. That's where x equals 0. And your x-intercept is going to be there, where y equals 0. Okay. All right. So I want to graph. Let's try this example. And the purpose of this is to see the effect of the y-intercept on a graph. So it says graph y equals 2x and y equals 2x plus 4. Okay, so anytime where you have a line, so this is the equation for a line, and it's in slope intercept form. Anytime you don't have a y-intercept, so notice how there's nothing here. It's 2x, basically it's y equals 2x plus 0. So your y-intercept is 0. Anytime your y-intercept is 0, that line is going to end up crossing the x. It's going to end up crossing the origin. Okay, that's the origin. Something I forgot to, I think, point out when we were going over the coordinate system was the origin. Okay, the origin is where x equals 0 and y equals 0. Okay, Anytime, yeah. So anytime you don't have a y-intercept, in other words, when the y-intercept is 0, it's always going to cross the origin. So 2x is just going to be, we're going to start at 0, right? We went over graphing last time, right?
Yeah.
Yeah, so we're going to start at 0, and the slope tells us, so a slope of 2 means the slope is, it's the same thing as saying the slope is 2 over 1. In other words, rise over run, where rise is 2 and run is 1. Okay, you're going to move two units up, 1, 2, and you're going to move 1 unit to the right.
Yeah.
How would we, what would our rise over run be if I wanted to, instead of going right, I wanted to extend this graph to the left? So if I'm going right, I'm starting at the origin and I'm going 2 steps up and 1 step to the right. But if I want to go left, what would I do?
Two steps to the left.
So you would do the opposite of what's happening here. So instead of going up 2, you're going down 2.
Oh, okay.
And you're going left 1. You're doing the opposite. So it's the opposite. When you're going right, the slope is always 2 over 1 for this specific example. But if you want to, for whatever reason, you wanted to extend the graph to your left, you would have to do the opposite of that slope, which is going down 2 and to the left 1.
Yeah.
Okay? All right, so the slope of 2x is going to look like this. I'm going to label this y equals 2x. And the line y equals 2x plus 4 is going to look like this. So we're going to start at y equals 4, okay, the y-intercept. And we're going to move 2 units up and 1 unit to the right. And we're going to extend this graph because I want to draw it. I can't extend this graph to the right more because I don't have any room right here. So I'm going to extend this graph to the left. I'm going to do the opposite. So I'm going to move down 2 and to the left 1. So 2 units to the left, 2 units down, 1 unit left. Like that. Then I'm going to, and then I'm going to draw a line. So there's our 2 lines. So this is y equals 2x plus 4. Now, having drawn y equals 2x and y equals 2x plus 4, can you guess as to what the plus 4 is doing to the graph? So, in other words, if we start with this one and we were to add 4 as an intercept, what is it doing to the graph?
It's gonna go up on the y-axis by 4.
Yeah, it's basically a shift upwards of 4 units. And there's a property of this line that you can kind of get from just looking at it. What kind of lines are these 2 lines? What do they look like to you? Geometrically, what do they look like to you? They're 2 lines that look like they're going in the same direction.
Perpendicular.
Well, isn't perpendicular when there are 2 lines that are at right angles to each other? What happens if they're together like that? They go in the same direction.
They're equal.
So this is perpendicular. If 2 lines are intersecting at a 90-degree angle, it's perpendicular. Do you remember from geometry what lines, what is this called? 2 lines going in the same
I forgot the word for it.
Parallel.
Oh, okay.
So these 2 lines are parallel. Okay? And we're going to go over that in the next lesson. But the thing you need to know about parallel lines is we don't have to graph parallel lines to know they're parallel. We can just look at their equations because they'll have the same slope. the intercept can be different, but they'll have exactly the same slope. Okay, parallel lines.
Yeah.
Okay, now let's go over an example. It says find the slope and y-intercept of the following line. So the general form again is y equals mx plus b, where m is your slope and b is your y-intercept. So in this example, in this equation, what is our slope?
Y.
So
Oh,
if
wait, no, 3/5.
yeah, the 3/5 is the slope, and what is our y-intercept?
2.
2. Good. Okay. Let's go to the next example. It says use the following information to write the equation of a line in slope-intercept form. So we'll just do it. Bless you. We'll just do this together. So again, just recall that the slope-intercept form is y equals mx plus b. So you would just put this information in this form is what this example is telling you to do. So as an equation, it would be y equals, the slope is what?
3/4
Yeah. Oh.
with an x.
So 3/4 x, and then the y-intercept is
Yeah, plus 1.
1. Okay, yeah. So there it is. Y equals 3/4x plus 1. Okay, your turn. It says use the following equation of a line and slope. Use the following information to write the equation of a line in slope-intercept form. Okay? And let me know when you're done.
I'm done.
Okay, so did you get something like this?
Yeah.
Yeah. Slope is 0. You don't have to do plus 0. You can just write it like this.
Yep.
All right. Next example. It says find the slope and y-intercept of the following equation for a line. So we have 3x minus 5y equals 15. And we want the slope and the y-intercept. So the easiest way to identify the slope and y-intercept when we're given an equation and it's not in slope-intercept form is to put it in slope-intercept form. In other words, you would solve for what? What variable would you solve for to put it in slope-intercept form?
X.
Okay, let's have a look. So this is our slope-intercept form. It says y equals mx plus b, right?
Oh, yeah.
So I'm going to ask you one more time. What are we solving for? What would we solve for?
Y.
Yeah, we'd solve for y. So it would be negative 5y equals, I would subtract 3x from both sides to move it to the other side. And when I do that, I get negative 3x plus 15. And then I would divide each term by the negative 5 to get rid of the negative 5 in front of the y. And when I do that, I end up with y equals negative 3 divided by negative 5 is 3/5. Okay, the negative divided by negative is a positive, so 3/5x. And then positive 15 divided by negative 5 is negative 3. So here is our slope-intercept form. And what is the slope?
3/5.
Yeah, slope is 3/5, and the y-intercept?
-3.
Negative 3, good. So in the answer, I would write it as m equals 3/5, slope equals 3/5, and y-intercept is going to equal -3. Good. All right, your turn. It says find the slope and y-intercept of the following equation for a line. We have -5y equals -x minus 10. Let me know when you're done.
And then
Okay. Give me 1 second. Okay. So, what will we do to put this in slope-intercept form? What is our first step?
divide each side by -5.
Mm-hmm. So that cancels out to -5, so we're left with y equals, and we have negative x over -5. That's the same thing as 1/5, right? Because we have a negative, so there's a -1 here.
One
Okay.
fifth x.
Yeah, 1/5 x, and then -10 divided by -5.
+2.
+2, good. And what is our slope?
1/5.
Okay. And our y-intercept?
2.
Good. 2. All right. So that's our answer for that one. And let's try another one. It says it's important. So why is this important? Same type of problem. It says use only the slope and the y-intercept to graph. Okay, so this is trying to demonstrate to you the idea of how easy it is to graph equations using the slope-intercept form. Okay, and there's a lot of many ways to graph lines, but to me, and I think to anyone who has taken algebra and has moved on to pre-calculus and calculus, will tell you that this is indeed the easiest way to graph a line. Okay, because what it does is it just tells you where to go. So y equals 6. You're gonna go to y equals 6 or 0, 6, because that's the y-intercept. 1, 2, 3, 4, 5, 6. You're going to mark that point. Okay, 0, 6. And then you're gonna use your slope to graph however many points you want. So what is the slope?
-3/4.
Yeah, -3/4. The rise is -3. In other words, do you move down or up?
Down.
Down. You're going to go down 3, and then are you going to go left or right 4 units?
Left.
So the slope is -3/4. So you said the rise is going down 3 units. What would be the run be?
4. To the right.
To the right 4 units. Good. So you would go down 3 units. 1, 2, 3. And then you would go right 4 units. So 1, 2, 3, 1, 2, 3, 4. Right here.
Yeah.
And all you need is 2 points for a line. But sometimes I think some teachers will want more than 2 points. So you could extend this by another point. So let's do that. Let's go down 3 more steps. 1, 2, 3. And then go right 4 units. Okay? So here's, so we have 3 points. We're going to connect our points with a line. And there's our graph. We have, make sure you label your axes, x and y. And does this line make sense to you when you're looking at this equation?
Yeah.
Why does it make sense to you?
As like you can clearly see the y-intercept and the slope.
And is the slope positive or negative?
Negative.
The slope is negative, and is the line going down or up?
Down.
Yeah. That's one way you can. There's something called the reasonability test where you solve a problem and you ask yourself, does this answer seem reasonable given the problem? And you can clearly see that the equation has a negative slope, and the line that you've drawn is also negative. It's got a negative slope. As you're moving from left to right, it's sloping down. Okay?
Yeah.
Yeah. Okay, so let's try some more examples. Your turn. It says graph the equation using the slope-intercept form. We have 4x minus 3y equals -9. And let me know when you're done. Am I coming off loud to you? Am I
No, you sound fine.
okay? Because I don't want to. I want you to hear me, but I don't want to sound like I'm yelling all the time. So
I'm done.
okay. So what are we gonna? So first of all, are we solving for x or y?
Why?
Y. We're solving for y, and what is our first step to doing that?
Um, we turn it into slope-intercept form into the equation. So I divided each side of the equation by -3.
Okay, but before we do that, what do I have to do with this 4x?
You move it to the other side.
Yeah, so I'm gonna subtract it from both sides. And when I do that, I get -3y equals, I have this -4x minus 9. So you said divide both sides by -3?
Uh, yeah.
Yeah, to isolate y, right?
Yep.
Yeah. So I'm going to divide each term by -3. That's going to get rid of the -3's over there on the left side. I have y equals -4 divided by -3 is just going to be 4 over 3. X, yeah. And then what is -3 divided by -9?
+3.
+3, good. And so, okay, so this question wanted us to graph. Did you graph?
Yeah.
Okay. So we're going to move up to 0, 3, our y-intercept.
Yeah.
And then we're going to use the slope to graph our other point. So it says 4, 3. What's our rise?
4.
What's our run?
3.
Okay, both are positive, so we're going to move up 4 and then move right 3 units. We have 2 points. That's enough for a graph, and we're going to draw a graph. And does this line make sense to you?
Yeah.
Yeah, the slope is positive, and the line slopes up, so there's our line. Okay, good. All right, the next form of a line is called a point slope form, and the general form of the line looks like this. We have y minus y sub 1 equals m times x minus x sub 1, where m is the slope. Okay, and this is given a point. So we have x sub 1 and y sub 1 as a point that we've been given. So then once you're given a slope and a point, this point right here, we can simply use this equation to write out our equation in point slope form. So let's do that. Example, it says write the equation of the line going through 0.34, and slope equals -2. Okay, all you have to do is use the formula. So y, okay, what was the formula? It was y minus y sub 1 equals slope times the quantity of x minus x sub 1. So it's going to be y minus 4 equals, we have -2, the slope, and then x minus x sub 1, which is 3. And you can just leave it that way. Because that is the point slope form. Okay?
Yeah.
Okay. By the way, you can convert this to y-intercept form, the one that we learned about previously just now. How do we do that? Do you know?
Convert what?
You can so this is the point slope form. How would we convert it to the slope intercept form?
You would take the 3 and 4 and I don't know.
Okay, so one way you could do that is to actually solve for y, right? All you got to do is solve for y if you want to put it in slope intercept form. In other words, you're going to distribute this negative 2 across the x minus 3 and solve for y. So if we did that, it would be y minus 4 equals negative 2,
Negative 2x.
and then positive 6. Add 4 to both sides. We get y equals negative 2x. Sorry, this is 4. So 6 plus 4 is 10. And that would be our line in slope-intercept form. So this is slope, int, slope-intercept, and this is slope form. Okay?
Yeah.
All right, and you have to know, I think, either in your homework or quizzes or your tests, your SATs, I think some of the questions might deal with you converting from one to the other. Okay?
Yeah.
All right, your turn. So it says, write the equation of the line going through the point 0, 2 and m equals 5. And let me know when you're done. And you're gonna, sorry, I didn't specify. Write the equation in point slope form.
Can you write the formula down?
Yeah, it's y minus y sub 1 equals m times the quantity of x minus x sub 1, where you're given a point of x sub 1 and y sub 1.
Okay.
Okay, so this is the point that you're given, and this is your slope. And as you do these, you keep doing these things, you should be able to simply just memorize it.
Yeah. I'm done.
Okay, so when we plug our information in, we get y minus 2 equals, the slope is 5, and then x minus 0. So you might be able to get away with just leaving it in this form, but because you have a negative 0 here, you probably want to simplify it by doing that. Okay? Is that what you got?
Yeah.
Okay, good. All right, your turn. It says write the equation of the line going through negative 1 and 5 and 4 and 10, and write the equation in both slope-intercept and point-slope form. So notice how it's not giving you a slope, but it gave you 2 points. So are you able to figure out the slope using the 2 points?
Yeah.
Yeah. So there's a hint. So I want 2 equations, one in slope-intercept form and one in point-slope form. It's giving you 2 points that's on the line, which would allow you to solve for the slope.
I'm done.
All right. Okay, so the first thing I would do is solve for the slope. So we're given 2 points. So it's the change in y over the change in x. So I would do 10 minus 5 over 4 minus a negative 1. I have two negatives, so I'm going to convert them to positive. And then 10 minus 5 is 5. 4 plus 1 is 5. 5 over 5 is 1. So our slope is going to be 1.
Yeah.
Yeah. And then for the slope-intercept form, so you could try to get the point slope first because notice how you have a slope and you have 2 points. So you could use one of those points to write an equation in point slope form first.
Yeah, I did that.
Okay, what I would do is this. Sometimes people do this. So I know my slope intercept form is y equals mx plus b. I know my slope. It's 1. So what's happening? So I can write the equation as x, okay, because slope is 1, plus b. And I know that I have these points. So what I could do is plug -1, 5, or 4 and 10 and solve for b that way. So I'm going to do that. So I'm going to use one of these points. I have -1 and 5. So y would be 5 if I did that, and then x would be -1. So yeah, -1. Okay, and the reason why there's nothing in front of this x right here is because the slope is just 1, as a reminder. And so what do I have here? After plugging in the information, -1 and 5, into this equation, I have 5 equals -1 plus b. Well, guess what? I can simply solve for the y-intercept by solving for b. So I'm going to do that. I'm going to add 1 to both sides. And when I do that, I get b equals 6. So the y-intercept is 6. Is that what you have for the y-intercept?
Yeah.
Yeah. So I got the same answer. I used a different method and got the same answer. Now I can write an equation in slope-intercept form because I have slope and then I have y-intercept. So I'm going to write y equals 1x, or just x, plus 6. There's my slope-intercept form. In point slope form, I'm going to do y minus, and I'll use 4 and 10 this time. Y minus 10 equals, slope is 1, so I don't have to write anything. If I wanted to, I could just do that, but slope is going to be 1. So, and then I have x minus 4. And then I'm going to, actually, yeah, that is our point slope form. So our point slope form is going to be this. Is this what you got for your point slope form?
Yes.
Yeah? Okay. Okay, good. So let's say you did the point slope form first. And now you have to get your slope intercept form. Well, all you would have to do is solve for y. So it would be y minus 10 equals x minus 4. I would add 10 to both sides. And what happens? I get y equals x, -4, and 10 is positive 6. And guess what? That is our slope intercept form. Okay?
Mm-hmm.
All right, good. Okay, now we move on to the final form, which is the standard form. And the general form of the standard form is ax plus b equals c, where all 3 coefficients or constants, so a, b, and c, are all integers. So we're not dealing with things like fractions or decimals, stuff like that. And that's your x variable, and that's your y variable. Okay, so if an equation comes in this form, it's going to be called the standard form. So let's try it out an example. It says, write the following equation in standard form. What form is this in?
Slope-intercept
Yeah,
form.
that is the slope-intercept form. And to put it in standard form, it would have to look like this. So let's do that. So that means I would have to move the 2 over 5x to the other side. And how would I do that?
Um,
How would I move 2/5
divide
x?
y by, wait, yeah. You, divide y, you subtract 3.
So, okay, I'm trying to find a way to. So this is, in terms of our general form, this 2/5 x is ax. And this is y. So all I would have to do to move it to the other side, to the left side, is to subtract it from both sides, right?
Yeah.
Yeah. So when I do that, I get y minus 2/5 x equals 3, positive 3. And
Yeah.
notice how this doesn't look like our general form. And actually, you want to change the ordering because the x comes first. So I'm going to do that. I'm going to change the ordering to negative 2/5 x plus y equals 3. And guess what? We're still not done because we specifically said that we want integers.
Integers?
Yeah.
Yeah.
And 2/5 is a fraction, not an integer. So how would we get rid of this fraction?
Um,
What did we do before to get rid of fractions when solving
you
for equations?
multiply the entire equation by the denominator.
Denominator. Yeah, so the least common multiple of the denominator, but the least common multiple of this thing is 5 because the denominator of y is 1 and the denominator of 3 is 1. So it's just 5. And when I do that, multiply both the left side and the right side by 5, I get negative 2x plus 5y equals 15. And yeah, so to me, this is an acceptable answer. Negative 2x plus 5y equals 15 is in standard form, but some people are going to go one step further and get rid of this negative. So how would I get rid of that negative?
You multiply it by itself.
Yeah, you either multiply or divide both sides by negative 1. So when I do that, what happens is the signs flip. So negative times a negative is a positive, so I get 2x, negative 5y, and negative 15. And some teachers are going to want this right here. Okay, in other words, I've gotten rid of this negative right here in front of the 2 by multiplying both sides by negative. Now, you might be thinking, well, the general form has a plus, right? It has ax plus by equals c. The reason why this is a correct answer is because it can be written as a sum. So 2x plus negative 5y equals negative 15. In other words, every subtraction problem can be written as a sum. Okay? Just in case you were thinking that. If you were looking at this and saying, why is that the general form? There's a negative here. Well, that's why, because every subtraction problem can be rewritten as a sum like this. That's why a lot of times when you have things like rules and properties and theories that apply to sums, it also applies to differences as well.
Yep.
Okay, your turn. So write the following equation in standard form and let me know when you're done. It's y equals 1 half x plus 5.
I'm done.
Okay. So since we want integers as coefficients, I would just start by multiplying the whole thing by 2 to get rid of this 2. In other words, to get rid of the fraction. So I end up with 2y equals x. Okay, 2 times 1 half is 1, so I just get x. And then 2 times 5 is 10. And then I'm going to move this x to the left side by subtracting it from both sides. And when I do that, I get negative x. Remember, you want the general form of the standard form wants the x first, and then it wants the y second. So I want negative x plus 2y equals 10. And I think this is acceptable, but some teachers are going to want to get rid of this negative. So I'm going to multiply both sides by negative. And when I do that, I get x minus 2y equals negative 10.
I got that.
You got that?
Yeah.
Okay, very good. Very, very good. Okay. All right, so that's it for today. However, I want to just quickly refresh the 3 forms. Point slope form. Do you remember what the general form of the point slope form looks like? Sorry, not point slope form, the slope intercept form.
Y equals mx plus b.
Yeah, it's y equals mx plus b. This is one of the most fundamental equations there is in algebra. And second, what about the point slope form?
Y minus y subscript 1 equals m times x minus x subscript 1.
Yeah, so y minus y sub 1 equals m times the quantity of x minus x sub 1. And what about the standard form?
A times x plus b times y equals c.
Yeah, ax plus b equals c, where a, b, c are integers.
Yeah.
Very good. So, did you do the assignment already?
Which one? Because I think I forgot.
So, it was equations of a line, this one.
I'm pretty sure I did that.
Okay. All right, so are you sure?
Oh wait, actually no, I
No?
didn't.
Okay. So that's due tomorrow.
Okay.
Okay. Good job.
Okay, bye.
Bye bye.